The most important task we have planned for the Great Wall 9 is to build solar power stations in space. Some people may say that using the Great Wall 9 to send solar panels is not a big use of space. Don't ever think so. Building space power stations is one of the most pragmatic plans for space development. At a time when human beings on Earth are demanding more and more energy, fossil energy is being consumed more and more. How to achieve sustainable development of human energy has become an important challenge for all major countries. For mankind, solar energy is inexhaustible. The vast majority of the sun's rays in space are diverted around the Earth into deep space. How can we put this sunlight to use? Einstein's assistant Dyson came up with a way to get all the solar energy by wrapping the sun around it, called a Dyson sphere. Although the Dyson sphere is really difficult to implement for current human technology. But humans have been harnessing solar energy in space for decades, and building a solar power station in orbit around the Earth is still possible. The best solution would be to build a large solar power plant in geosynchronous orbit. This is because geosynchronous orbit can be used to generate electricity almost 24/7, with no day or night. Only around the spring and autumn equinoxes is the Earth blocked for a period of time each day. A synchronous orbital solar power plant can transmit electricity back to Earth without interruption via microwaves, independent of the Earth's weather. Such a scheme is very tempting, and plans for solar power stations were proposed on Earth more than 50 years ago. The earliest proposal was naturally the US proposal to build a 5-gigawatt solar power plant, which was a very ambitious plan at the time, as it was aimed at generating half of the country's electricity. In addition to the USA, the Soviet Union, Europe and Japan have also long proposed solar power plants and have carried out a great deal of technical research. Japan, in particular, came up with plans for the construction of power stations in 2009, to start construction of several power supply stations in 2030 and to build power receiving stations in the Pacific Ocean. Their technological reserves in wireless power transmission are ahead of the world. The introduction of space power stations has been more active in recent years. There is also South Korea, which organizes annual technical seminars and presents its own program for the construction of space power stations. China only formally began its research in 2006, when its technology reserves were relatively small and it was not considered a major force in the planning of space solar power station construction. But the biggest barrier to the construction of space power stations is the capacity of rockets. Without heavy rockets, the construction of space power stations would be a very long process. For example, the solar power station to be built in China is 200 megawatts, and the mass of the electromechanical station must be at least 1 or 2,000 tons. At the same time, this power station to be built to geosynchronous orbit, according to the current capacity of the most bullish rocket Long March 5 at least need 1 or 200 times to complete, even if the Long March 9 to transport also need dozens of times to do. Because the Long March 9 geosynchronous transfer orbit capacity is only about 50 tons, dozens of launches will be needed by 2035 after the Long March 9 is put into operation in 2030. On average, several launches will be required each year. Of course, the direct launch option would be too difficult, and it is likely that the 140-ton capacity of the Long March 9 in near-Earth orbit would be used to launch in batches. Small modules would first be assembled in NEO and then sent to GEO for further assembly. Even with the high frequency of such a program, there would have to be monthly launches. The Long March 9 is not destined to be too leisurely, and a once or twice a year launch like the Long March 5 is not possible. This 200 megawatts power station is also just a preliminary power station, and in order to expand to the GW level, even more power stations may have to be replicated. So our Long March 9 is definitely not a face-saving project. It will be a very busy big rocket. Talking about this, I can only say that the title of Chinese infrastructure mania is definitely not called for nothing, and this awareness awareness is now gradually becoming widespread above the international community. Moving on to space power plants, at a time when the US and Europe are not active in building space power plants, the only countries that really have the strength to complete the construction of space power plants are China, Japan and South Korea. It is unlikely that a heavy rocket will be developed in the short term, and the launch of the power station is a problem. Japan has already postponed the official construction of its space power station from 2030 to 2050, and China, as a latecomer, is building its own space station, taking the lead in using ultra-thin, foldable, high-efficiency solar panels. New solar panel technologies are being validated, as well as a movable robotic arm and an electric propulsion system, all of which are necessary for the construction of future solar power stations. In addition, China is planning a ground-based power receiving station to conduct experiments on the transmission of solar power from near-Earth orbit to the ground in 2025. There should be little doubt that China will be the first to build a truly space-based solar power plant by 2035. Why is China in such a hurry to undertake this construction? Because it has launched a strategic plan for carbon peaking and carbon neutrality, with carbon peaking in 2030 and carbon neutrality in 2060. In order to achieve this ambitious goal, there will be an annual investment scale of $2 trillion to $4 trillion as a reserve of supporting technologies. It is definitely not a waste for the country to spend hundreds of billions of dollars to build space power stations and seize the technological high ground.